On our last episode of logarithms, we were talking about the orders of magnitude. We need to move on to the next example. See what I have to say. Oh, psst. Forgot to unmute it.
Science example of an
Let's go back and see what I...
this time.
Okay,
Not a log
stop.
function, but an exponential.
Let's go back here just a little bit. Click. Come on. Why isn't it? Oh, because I'm on the wrong thing. I see.
Of cooling, this is another science example of an exponential function this time.
You do not need to memorize this formula. Okay? This is a decently complicated example. It's meant to be practice. It is not meant. This is not a test question, but this is good practice and something to think through. We can practice our different skills of solving with this, but this is not going to be a test question.
Not a log function, but an exponential function. An object has been heated.
Okay. Do not panic. You are not being asked to memorize Newton's law of cooling. I just said that.
If you need it, you will be given that function on a
Yeah,
test.
if you need it. No,
All right.
we're not giving it to
Along
him.
with the description.
'Cause we're not
of
asking
every
it.
one of those objects so that you would know how to use them. Okay?
It's just a good practice problem.
Anyway, just thought I'd let you know so you're not panicking.
Yeah, don't panic.
Well, cool.
Cool.
The medium in which it is placed in. All right. So if you have a cup of coffee and it's in your kitchen, the air temperature of the kitchen would be the surrounding air, and it has a particular temperature. Typically, the coffee's hotter, so it's cooling to that temperature.
Right. Surrounding medium is not to be confused with surrounding large or surrounding extra large.
Okay, coming down. It says an appropriate value of K, and that K would belong to that particular situation, or that coffee, that liquid, or whatever the medium the object that you're cooling.
Don't yawn. Don't do this to them. By appropriate value of K, we also don't mean something inappropriate for children such as yourself. We wouldn't want an inappropriate value of K to be seen on screen.
T sub 0 is the initial temperature of the object. In my case, what I just mentioned was a coffee cup. This is something that's interesting, and this makes sense. The temperature of that coffee cup, as you go infinite amount of time, will get closer and closer and closer to the temperature of the air in the room.
Yeah, that makes sense.
So in other words, that's what
Can't go below that.
The limit is definitely existing in this case, folks.
Yeah.
So here's an example that I copied some of it, but not all of it, because I wanted to work some of it out with you. Hard-boiled egg at temperature 96 degrees Celsius is placed in 16 degrees Celsius water to cool.
Okay.
4 minutes later, the temperature of the egg is 45.
Don't yawn. Stop it.
Use Newton's law of cooling to determine when the egg will be 20. Okay. So, we've got things that we can plug in here. T sub 0, that's, your 96. Your air temperature is 16, and that's where the 80 is coming from.
So our original temperature is 96, and then the air temperature is 16, and so obviously it's going to travel from the 96 down to the 16. We don't know how much time it's going to take to do that. And the process of all the information that we've been given at the beginning is solely, for the first part of this, is just to figure out what K is. I mean, right? Oops, sorry, don't do that. I keep doing that. It's solely to figure out what the value of K is. Now, but that's only the first part of the question. There's going to be a second part of the question. That's why I would never ask this on a test, because it's too much all at one time in one problem. Anyway, let's see what else I have to say.
plus your 16, and that's where this is coming from. The thing that we don't have, or maybe we do have, and that's where
45.
this stuff comes into play.
Right, you're 45.
After 4 minutes, the temperature is 45.
So we actually measured the temperature. We clocked the temperature from 96 to 45 degrees. It took us 4 minutes. So we're using that to find our K value for this particular situation, and then we're going to use that information to estimate how long it'll take to figure out, okay, here's a new temperature, how long is it going to take to get there?
They inserted that into the formula, right? They inserted that value for T here and T, little t and capital T.
It's a lot of T's.
So when they do that, we can start solving this, right? We can bring the 16 over to the other side by
Okay, good idea.
subtracting. Of course, that's going to give me 29.
Amen.
And then we're going to divide by 80.
True.
And using my handy dandy calculator.
0.3625.
0.3625. Okay.
Man, it's like an echo in the room.
3625. All right, now, how do I solve this thing? Well, I got to change it to its other form, right?
Is this going to be the degenerate log? Do we need the degenerate log? You're asking me what is the degenerate log? The degenerate log. Oh, Ellen. Oh, that's mine, by the way. You cannot use that. That's my joke. And Ellen is base E. Oh, that is so good. Oh my goodness, this gets even better. All right. So using the degenerate log, we will continue.
Natural log 0.3625
equals what? Exponent. Remember, logarithm equals exponent. You've got to remember that. So many of you are not getting that, catching or picking up on that point. Natural, whether it's a natural log or any other base log equals exponent.
Equals negative 4k. And I will jump over here and type that. Natural log, I'm going to use the answer feature. Get that, and then of course we're going to divide by negative 4.
Yep, don't forget that.
So we end up getting a value that disappeared from my screen because I wasn't fast enough to grab it.
Oh my goodness.
0.254. Okay, so that's the K value for this particular situation.
That's
right?
part one of this question.
That's not the complete answer to my question.
That's right, it
Remember,
isn't.
my question was using Newton's law to determine when the egg will be 20 degrees. So now I got to take that value of K and use it, right? We know the temperature will be 20. That's what we're looking for. All right, and so now we have 16 plus 80 E.
Now, where did the 80 come from again? That was the difference in the temperatures. Come on. So we had a 96 degree temperature and we were going down to 16. That's where this 80 is coming from. Not that I need to redo that, but I just wanted to make sure you knew that's where the 80 came from in this particular problem. And
to the negative, what was it again?
0.254.
0.254.
Oh man, now it's out of that.
0.254, and I'll probably use the calculator version of that so it's more accurate. And we'll push this to the other side.
4.
By subtraction will give us 4. divide out the 80. That'll give me 0.05, right?
Yeah, because that's 1 over 20. And if you had 1 nickel in your hand, that would be $0.05, in case you're wondering. Okay?
That's 1 over 20, which is like a nickel, folks.
Oh my
0.05.
goodness.
All right, and then
I
I
feel
can
like-
change it to its other form.
I feel like I
Natural
am
log
going crazy.
0.05 equals, oops, no E anymore. What am I thinking?
That's right.
Mr. Staley.
That's right. You got the degenerate log. You don't need E
And then,
anymore.
of course, we'll divide by that negative
At least to a power.
value. And work our magic on the old calculator. And we're almost done here, folks. Whoops, lost it. Natural log 0.05.
Come on, type.
And then we're,
Whoops, don't forget.
very important I back up and use that
Yeah.
parenthesis there. Otherwise, I'm going to get the wrong answer.
That's right. Don't forget that end parenthesis after the natural
Why am I
log.
doing that?
Woo.
Let's just be smart about this.
Yep.
Use the answer from the last question.
Oh,
Get the most
that's going to
accurate
be
value.
wrong.
So my time, say what? Oh, I forgot the negative.
That's right. I forgot that little
So-
negative.
Obviously, I can take care of that.
Right there, I
easily
forgot
by dividing
that.
by negative 1. So 11.8 minutes. T equals 11.8 minutes. For that to get to that temperature. And
Okay, so just keep in mind, that's a big question, multi-step problem. I use it as practice. I'm not putting that on the test.
don't believe. Oh, there's some math Excel things that I wanted to go through with you. Here, I'll zoom out a little bit so you can see this question. State the domain of the function. So yes, you can go to Desmos and graph that, but I want you to think about what's inside here. Okay, first of all, we know on a basic log function that this thing inside here cannot be 0 and it cannot be negative. So 2x over x plus 7 has to be greater than 0. Okay? Now, that looks like what we did with our rational functions, right?
Amen.
We could think about this as having a vertical asymptote over here at x equals negative 7, and we could find, the y, it goes through 0 because it's got a y-intercept of 0 or an x-intercept of 0. We know that because we can get that from the numerator. It also has a horizontal asymptote, at 2, right? Find your. So all of that stuff, we should know
Right.
from the
You
last
should know
chapter.
that.
But if we do our little, positive negative trick, with the, picking values and plugging them in, little sign chart stuff. So if I plug in negative 8, negative 8 would give me a negative on top and a negative on the bottom. So over here it's positive. So in between the vertical asymptote and the 0, let's pick something like, I don't know, negative 5. That's in there. So that would give me a
Okay.
negative on top
Yep.
and a positive on the bottom. So overall, this section in here would be negative. And then something past 0, let's say I plug in a 1, that would give me a positive on the top and a positive on the bottom. So there's actually 2 sections where it's positive, okay? Not just one section. And I believe if you look at the graph, you're going to get something like, I think it's this one right here.
Now, I am going to allow you to use a graphing calculator, but some of you still need the logic of knowing what you can and cannot get or put in that function. All right? Since it cannot be equal to 0, it cannot even be, you can't include this point right here. You can't include 0 because that would cause a problem for the natural log function. So I can pick anything past 0. I can also pick anything on this side of not -3, -7. What am I doing? Of course, union, but nothing in the middle there, because those are all negative values, and the natural log cannot handle them. And I'll probably say the exact same thing here in a second.
We could jump over to Desmos and type that in real fast, just for fun. ln parenthesis 2x parenthesis divided by x plus 7. Oh, I was wrong. I think I was wrong. So there's 2 sections. Kind of looks like a hyperbola, so let me jump back to where I was at before. And so I chose incorrectly. It's actually going to be that
Bottom
one over
left.
there.
Yep, there it is.
But the key thing here is when they ask me for the domain, right? You're looking at this. What did I just do? Come on, let's not be dumb.
Yeah, don't be dumb.
It goes from -infinity to -7.
Yeah, just like I said earlier.
And then it jumps over and it goes from 0 to infinity. So there's this big missing gap between -7 and 0 where there's nothing in there. Kind of weird. I just thought I would bring that to your attention. Here's another one that's, this is just a, if you do a little fireproof form, it's a log function that's been vertically stretched. So it hasn't been shifted to the left. It's not like the log x squared like we saw a little bit ago. It's like this one right here. And the domain of that. So you're just vertically stretching it. So that's no big deal, right? Domain 0 to infinity. It's not changing just because you vertically stretched it.
Right. All right, so I'm going to modify how I do some of these types of questions. And if you're given a list of numbers, an x and a y list, and you're asked whether they're linear, exponential, what I'm expecting is that you can rule out certain things, okay? So if you look at a set of data and it looks like this, then I don't want you choosing a linear function, and I certainly don't want you choosing a log function. I mean, you need to know what linear functions and log functions look like. Out of this choice, I would hope that you would pick exponential or power, because you know the basic shapes of those, like exponential growth, right? You know what that looks like. Power functions. We talked about how some power functions, in quadrant 1 look like that. Some power functions look like that, So a power function has a curve to it. So this could be exponential or power. Now, if you gave me other choices like, could this be cubic? Sure. Cubic is a possibility. Quadratic's a possibility. Okay? But the ones that are not, linear and logarithmic. In fact, it might be better if I just ask you, name a couple functions that this one could not be, or let's say you do a scatter plot, and if you need help doing a scatter plot, if you get a set of data that looks like this, I don't want you choosing linear. I don't want you choosing exponential growth. You need to be thinking log function. You need to be thinking a power function. But definitely not linear, not quadratic, not cubic. I mean, you definitely need to think in terms of either a log or power function on something like that. So that's what I want to get at with these questions. We're not going to go through the process. When you get to stats, you're going to find a much more accurate way to make a decision on which one it is. Right now, we're just kind of giving you the basics of what they look like and and making choices between them. When you get to stats, you'll find that there is a much more exact way to do it. Okay, let's see if there's any more that I need to add to this video. And the answer to my question is nope, it's finished. And we'll do homework questions in class. Have a wonderful evening.